Hello, dear colleagues. My name is Pavel Maltsev. I am a second year postgraduate student of the Faculty of Construction and Architecture. I am currently studying the direction of environmental safety, and in this presentation, I would like to talk about my work on the topic development of the electromagnetic monitoring system for urbanized areas near power lines. In this presentation, we will propose a method for determining the intensity of the electric and magnetic fields. Let's get started. Electromagnetic environmental monitoring is a system for monitoring the state of the environment, assessing and predicting change in the state of the environment under influence of the electric and magnetic fields. The relevance of this topic is currently determined by the need to develop and implement methods for monitoring and assessing the environmental situation and ways to improve the protection of the environment and human in urbanized areas near power lines of various type and voltage classes, which is essential to ensure the sustainable development of the settlement and human protection from the negative effects of the electromagnetic pollution of the urban environment. The practical significance of the study is increasing every day because humans' life has changed a lot with the advent of the electrical application and electrical equipment. Their functioning requires more and more energy, which unfortunately has negative properties that affect the human body. The aim of the study to propose a convenient numerical method for studying the electric and magnetic fields of a high-voltage power line located between two stationary poles. Electric transmission lines are on the same straight line, parallel to each other. A special case. The object of the study is section of a high-voltage power transmission line, the section between two stationary poles located in Kursk region, the closest to the populated area. The tasks of the study. First one, to consider the available analytical methods for calculating an influence of the electric and magnetic fields, to study the available instrumental research methods for determining the intensity of the electric and magnetic fields. Third, to propose a method for determining the electric and magnetic field strength of a section of a high voltage power line located near residential buildings. In this work, the study of the electromagnetic fields of power transmission lines was carried out using an analytic method and a field strength measure of industrial frequency (PZ50). PZ50 is designed to measure the RMS value of the electric and magnetic fields strength excited by high-voltage electrical installation of the industrial frequency. The appearance of the PZ50 is shown in Figure 1. On this slide you can see the main elements of the device and its characteristics. The assessment of the levels of electromagnetic fields of power lines was carried out according the analytic calculation according to the formulas that we will given in the next paragraph. The electric and magnetic field strength was measured in position of the measuring antenna at a height of 1.775 meters above ground level. However, these instructions don't consider the case of measuring electric fields when turning the power line rod. In addition, there is currently no method for measuring and magnetic fields of power lines. To study electromagnetic pollution from the power lines in the city of Kurchatov, Russia, Kursk region, measurements of the electric and magnetic field strength on 115 kV power lines, 345 kV power lines, and 400 95 kilowatts power lines were carried out. Measurements were carried out at a height of 1.75 meters from the Earth's surface, using a meter of electric and magnetic fields intensity of industrial frequency PZ50 along the flight route on the power line. Slide number 6 is continuous of slide 5 and contains three more formulas. Slide 7 shows after conducting field studies, a table is provided to your attention that contains electromagnetic field along the span of the road, a table with the measured magnetic field strength H, and electric field strength E with the distance L between two supports of high-voltage power lines obtained from the results of the full-scale survey of the line in the Kurchatov using the industrial frequency field strength meter PZ50. This slide shows a graph of the electric field strength along a high-voltage power line. Slide 9 contains magnetic field strength along a high-voltage power transmission line. As a result of the conducted research, it was found that the level of electromagnetic radiation is the function of the nominal value of their voltage. The increasing voltage, the values of the electric and magnetic fields intensity increase. It should be noted that with the linear route of the power line, the electric and magnetic components reach the highest values at the points of the projection of the extreme wire to the ground, and the greatest amount of tension of observed at the point of maximum sagging of the wires in the middle of the span. Based on the conducted experiment, it was found that the excited method of measuring electromagnetic fields of the power transmission lines, according to which, in order to determine the RMS value of the electric magnetic field strength, measurement must be carried out at a selected point in the projection space of the electric magnetic field strength vector of three manuality orthogonal axes can be simplified. The values of the electric and magnetic field strength obtained by measurement differ from the corresponding value obtained by analytical technique by no more than 1.4%. This concludes my speech. Thank you for your attention, dear colleagues, and have a good day.